Lesson 32, simplifying and evaluating expressions with integer and zero exponents. Today in our new concepts, we're going to learn how to take on expressions that have an integer or a zero exponent in it and the rules that go behind how you simplify an expression with one of those exponents. Algebraic expressions may contain exponents that are positive, negative, or zero. The relationship between the different exponents can be understood by looking at the successive powers of positive integers greater than 1. Look at the powers of 2. For example, 2 to the fourth power, 16. 2 to the third power, which is 2 times 2 times 2 is 8. 2 to the second power is 4. And 2 to the first power is 2. You'd notice that as you're going down in power, the value is actually going in half for calculating what that looks like. In the left column, each entry is found by decreasing the exponent in the various entry by 1, so from 4 to 3 to 2 to 1. In the right column, each entry is found by having the previous entry or dividing it by 2, just how it happens to be the pattern. Use this pattern to find the next three powers. So 2 to the first power is 2, 2 to the 0 power, anything to the 0 power is 1, so that's again in half. Then 2 to the negative 1. If you go down by 1 again, this number should go in half. So what's half of 1? 1 half. If you go down one more and turn into negative 2, what's half of that? 1/4. The pattern illustrates the property of negative and zero exponents. So the property here in complex math terms says that anything to a negative power is just like that same power being positive, but in the denominator. See that? A negative exponent, so if there's a negative up here, it actually means that that entire thing is positive in the denominator right down here. For example, 2 to the negative second power is the same as 1 over 2 to the second power. 2 to the second power we said was 4, so it's 1 over 4, giving us the same answer. The zero exponent property shows us that anything to the zero power is exactly 1. An algebraic expression is not considered simplified if it contains a negative or zero exponent. The product property of exponents applies to negative and zero exponents as well. So if there's something we need to simplify, we cannot leave an exponent negative. It needs to be changed to positive in this form, in which you'd write it in the denominator with a 1 over the top of it. And if you have something that is being added or subtracted, the product property works. You're just going to add or subtract that negative number as well. In example 1, it asks you to simplify expressions with negative exponents. Here you've got x to the negative third. You take x to the negative third, make it positive, and write it underneath 1 in the denominator. Here in letter B, you've got y to the negative fourth over x squared. This portion in the top goes down into the denominator, and what was in the denominator stays there, so this can be written as a positive value. So you've got x squared y to the fourth in the denominator. Here you've got 1 over w to the negative fourth. If it's already negative and it's in the denominator, it's like it's reversed and it flips to the numerator in this case. So if it's negative in the denominator, it becomes positive in the numerator. I'll say that again. If it's negative in the denominator, it's positive in the numerator. If it's just a negative exponent overall, then it's positive in the denominator. In example 2, you're evaluating the expression with negative and zero exponents. So here you're going to put the zero exponent property into play and or applying how to simplify with a negative exponent. Letter A says a squared times b to the 0 power. Anything to the 0 power is 1, so you could simplify this as a squared. For this example, however, you have to plug in negative 2 and negative 3 for each of these values. So after you've simplified it, then you plug in negative 2. Negative 2 times 2 is 4, so it's solved because you've eliminated the b to the 0 because b to the 0 is the zero exponent property of 1. In letter B, you've got 3b to the negative third times b. What you're going to do here first is put these items together in terms of your product property of exponents. You've got b to the negative third, and this is b to the first power. Even though it's not written here, you could say that it's to the first power. So you'd have negative 3 and positive 1. That turns into negative 2. Now you can write that negative as a positive in the denominator. Take the b to the negative second, write it positively, but put it in the denominator. You've got 3 over b squared, and it's simplified in this form. Now you're going to plug in that value for b, which was negative 3. Negative 3 times negative 3 is going to be positive 9, so you get 3 over 9, which is simplified here to be 1/3. Next, we're going to learn about the quotient property of exponents. The product property of exponents says if their exponents are multiplied together, you can just add the exponents. Here you can actually just, if they're going to be divided, subtract those exponents. The quotient property of exponents is used when dividing algebraic expressions. This property states that to divide two algebraic expressions with the same base, subtract their exponents. So when there's division happening between those exponents, you're simply subtracting the exponents, the opposite of what you would be doing in the product property. So take a look at it, letter A. X to the 7th, x to the 3rd. You're going to treat this as 7 minus 3, which is 4, x to the 4th. In letter B, you've got x to the 3rd and x to the negative 7th. You've got 3 minus negative 7, so two negatives make a positive in this case, and it turns into a positive 10. Here's often what students don't do correctly, and they say 3 minus 7, and they think negative 4, but it's 3 minus a negative 7, so two negatives make that a positive in this case. Letter C says x to the negative 5th, y to the 6th, z over z to the negative 3rd, y squared, and x. Anytime you have all of these items that line up that are the same base, x, y, and z in the numerator and denominator, you've got to simplify those first. The first thing that it asks us to do is use the quotient property of exponents to do the subtraction between those items, and then you can simplify those. So you've got x to the negative 5th in the numerator, and you've got x to the first in the denominator, so it's x to negative 5 minus 1, which is going to give you negative 6. For the y's, you've got y to the 6th and y to the 2nd. It's 6 minus 2 is y to the 4th. And for the z's, you've got z to the 1st and z to the negative 3rd, so it's 1 minus negative 3, which would be two negatives, makes a positive. So here you'd have that positive 4. Then you take this negative exponent still and put that in the denominator as a positive value, and you've got that simplified. Okay? So you're subtracting the values for the x's, for the y's, for the z's, and if it's negative, then you're going to rewrite it as a positive value, but in the denominator of that portion. In example 4, it asks us to apply what we've learned in terms of the intensity of sound. The intensity of sound can be measured in watts per square meter. The table below lists intensity levels for some common sounds. And here the question asks you, how many times more intense is the sound of a rocket liftoff at 10 to the 3rd watts per square meter than regular speech at 10 to the negative 7th? You're going to write this out as a division problem because you're trying to compare how much more. So here you've got 10 to the 3rd divided by 10 to the negative 7th. You know that with the quotient property, you just simply subtract these. So you've got 3 minus negative 7. Two negatives makes a positive. So it would be 10 to the 10th times more. Or in this case, I believe that's 10 billion times more in terms of the intensity of that sound. In your lesson practice, Mr. Shane's going to go through these so that you can be prepared for what is coming in your assignment. Simplify each expression in letters A, B, and C. You're taking that negative value and writing it as a positive in the denominator. So here you would have 1 over x to the 5th. Here you would put the positive value in the denominator here. So you would have 1 over p to the 8th, q to the 4th. In letter C, you've got the negative that's already here. So you flip that up to the top and it becomes positive. So you've got d to the 8th as a positive value. In D and E, it says evaluate the expressions by plugging in 4, 6, and 3. The first thing that you're going to want to do is to simplify if you can. So here a to the 0 power is 1. So now I have b and c squared, so I only need to plug in those values. B is 6 and c is 3. So 3 times 3 is 9 times 6 is going to give me 54 for letter D. And for letter E, I've got 4 times a to the negative 2nd. To change that to a positive value, I would put it in the denominator. So I've got 4 over a to the 2nd. And a is 4, so it's 4 over 16. 4 over 16 is going to be equal to 1/4. In letters F, G, and H, you're simplifying each expression by using your quotient property. You've got 10 and 4, you would subtract those, which would be x to the 6th. You've got 9 and negative 2, you'd subtract those, get 9 minus negative 2 is going to be x to the 11th. And here where you've got multiple, you just have to line up those values and subtract those appropriately. So x is subtracted by x's, y is subtracted by y, and z is subtracted by z. In this case, you've got x to the 1st over x to the 2nd. So that would be subtracted as 1 minus 2, giving you 1 in the denominator. So x is going to stay in the denominator. Y is negative 3 and positive 2, so it's negative 3 minus 2. Same sign sum, that's going to be a negative 5, but it goes into the denominator. So you got y to the 5th in the denominator. And z, you've got to the 5th and to the 1st. 5 minus 1 is 4. So your final answer is z to the 4th in the numerator over x, y to the 5th. Okay? If you need to go back and re-listen to Mr. Shane's explanation of those to help you make sure you've got that understood, that would be helpful as you get to work on completing your assignment. God's blessings you're going to take care of in your assignment today all of the odd numbers, 1 through 30, but just the odd numbers. 1 through 30, just the odd numbers, or 1 through 29 if you want to make it odd. God's blessings.